Hi guys, I'm Catherine, and today I'll be going over touch and pain. The somatosensory system is responsible for all the touch that we feel. This includes light touch, pressure, vibration, temperature, texture, itch, and pain. These sensations are perceived with touch receptors whose nerve endings are located in different layers of our skin. In some areas, nerve cell endings wrap around the bases of hairs, responding to even the slightest hair movement, making them very sensitive. Signals from touch receptors travel along sensory nerve fibers that connect to neurons in the spinal cord. From there, the signals move upward to the thalamus and then to the somatosensory cortex. There, they're translated into touch perception. Myelinated nerve fibers with thick axons, called A-beta fibers, allow touch information to travel quickly, but other information is transmitted more slowly along thin, unmyelinated axons, or C fibers. Lips and fingertips are very sensitive, so they stimulate much larger regions of the cortex than less sensitive parts of the body. The sensitivity of different body regions actually depends on the number of receptors per unit area and the distance between them. For example, the touch receptors on your back are very few and far apart, so your back is much less sensitive than, say, your fingertips. 2-point discrimination is used by neurologists to measure sensitivity. The minimum distance between 2 points on the skin that a person can identify as distinct stimuli rather than a single one is the 2-point discrimination. Not surprisingly, acuity is the greatest in the most densely nerve-packed areas of the body, like the fingers and lips. By contrast, you can distinguish two stimuli on your back only if they are several centimeters apart. For pain, it's both a sensory experience and an emotional experience. The sensory experience signals tissue damage, while the emotional component makes the experience unpleasant and stressful. Pain is basically a warning signal, and it's basically the brain telling itself that something's wrong with the body. Special sensory fibers called nociceptors are used to respond to pain. Normally, they respond only to strong or high threshold stimuli, because it helps us detect when something is truly dangerous. There are different types of nociceptors that are sensitive to different types of pain. This includes thermal, which is hot or cold, mechanical, which is wounds, or chemical, which is toxins or venoms. Some types of nociceptors also respond to itch, which is, for example, histamine receptors are activated when skin irritation triggers the release of histamine. Pain messages travel to the spinal cord via small A-delta fibers and even smaller C fibers. The myelin sheath covering A-delta fibers helps the nerve impulses travel faster, and this is for immediate, sharp, and easily identified pain produced. The unmyelinated C fibers transmit pain messages more slowly, and this is for a dull and diffuse ache, or basically soreness. Pain and itch signals travel up to the spinal cord through the brainstem and then to the thalamus. From there, they're relayed to several areas of the cerebral cortex that monitor the body and transform pain into a conscious experience. The reason why different people feel different amounts of pain when exposed to the same pain stimulus is because of their emotional state, and also because of their setting. When pain messages arrive in the cortex, the brain can process them in different ways. The cortex sends pain messages to a region of the brainstem called the periaqueductal gray matter. Then, the periaqueductal gray matter activates descending pathways that modulate pain. These pathways also send messages to networks that release endorphins, which are basically the analgesic morphine of the body. Adrenaline is also produced in emotionally stressful situations, and this relieves pain without a loss of consciousness. The body's release of these chemicals helps regulate and reduce pain by intercepting pain signals ascending in the spinal cord and brainstem. However, the efficiency and sensitivity will influence how much pain a person feels, and this is also why some people develop chronic pain without responding to regular treatment.